On this week's episode of Lanagan's Laboratory.
Lanagan's Laboratory, yeah! Science roars in the air. Lanagan's Laboratory, yeah! Step inside if you dare.
Hey, boys and girls, I hope you had another great week. This is your fourth week here at Lanagan's Laboratory. This week, we looked at forces and energy. We learned that there are forces and energy that can't even be seen, like static electricity, magnetism, and gravity. On day one, we learned that static electricity is caused by a buildup of electrons on a surface. When the electrons transfer from one surface to another, you got more electrons on this surface than you do on this surface. And electrons and protons, they are attracted to one another. So now they're trying to get back together there. But if you have a surface that has too many electrons already or too many protons already, they will repel one another. See, both these surfaces are negatively charged, so they don't want to be next to each other. But if we have one object that is negatively charged and another object that is positively charged, opposites will attract. And the negative charges in the balloon are attracted to the positive charges in the wall, and it sticks to the wall. So, opposites attract, while like charges repel. We also did some experiments with gravity, and we learned that gravity pulls everything to the ground at the exact same pace, at the exact same speed, regardless of how heavy or how large an object is. But we also learned that sometimes here on Earth, wind resistance, air resistance, can slow certain items down, like feathers or balloons. But if there was some way we could pull all the air out of a room, all objects would fall at the exact same speed. On day two, we learned about circuits. We learned about how electricity travels through a circuit, and that when you open the switch, the electricity can no longer flow. The electrons have to stop flowing. But when you close the switch, the electrons can start flowing again and the light bulb lights up. We learned about the difference between a series circuit and a parallel circuit. How a series circuit, all of the components are on the same path to the power source. Whereas a parallel circuit, every individual component has its own path to the power source. So in a parallel circuit, you can turn on and off each light individually, whereas a series circuit, one switch would shut off all the lights, and when you turn that switch on, it would turn on all the lights. So you would wire something like your Christmas lights in a series circuit, but your house or the school building, we would want to light those in parallel circuits, so that when I turn off my lights, all of your teachers' lights don't turn off at the same time. Then we had a good time building our snap circuits, where we got to make a light bulb and an LED light up, and we got to make a helicopter fly. On our third day together, we learned that sound, light, heat, and motion are all evidence that there is energy present in a system. We learned that sometimes these energies could transfer from one to another. We learned how sound can transfer into motion energy. And we learned that light is associated with heat. As you see, this little number in the corner is the temperature, and the temperature is going up once we place it under the light. We also learned that even though gravity pulls on all things the same, that if gravity has more time to pull on one object than it does another, the object that has more time with gravity will go faster.
3, 2, 1, go.
We learned that magnets have an invisible magnetic field where it's coming out of the north and going into the south pole of the magnet. When two north poles are facing each other, their magnetic fields will be pushing against each other, causing the two magnets to repel.
Get away!
When two south poles are facing each other, the magnetic fields will also push against each other, causing them to repel.
Back off!
But when a north pole and a south pole are facing each other, the magnetic fields pull on each other, or it'll come out of the north and go into the south of the other magnet, pulling it towards it, and the two magnets will attract. So, basically, just like with the electrons, opposites will attract, but when they're alike, they will repel. Opposites attract, alike repel. We also learned that you can use the repulsion of magnets to make things move without touching each other. We played a game where we made our magnets move across the table, but we also learned that this is how bullet trains and some other moving objects work. They use the repulsion of magnets to push them along the track. And stay tuned for next week where we're going to learn all about our solar system. See you next time on
Lanagan's Laboratory!